Why, hello, everyone. Today, we're going to talk about, as you can see on 5.1, we're going to use your book, Relations and Functions. Or if you're watching from somewhere and you don't have a book, you could still learn about relations and functions. We are on page 65, so make sure you've turned to there. And this is one of my favorite lessons, only because of the fake Redbox DVD vending machine that they have in here that they use as an example with mock movie titles like The Hunger Sports, The Revengers, Battle Sales, The Amazing Insect Man, The Dependables, and The Light Knight, uh, as to not have copyright infringement. So, what we're going to talk about really here is first, what's a relation and what's a function, or that's what we're going to lead ourselves into. So, a relation is just there's a relationship between the two things. Okay, you have one thing, you have another. A and one have a relationship, and it gives you the hunger sports if you were to hit that button. So that's the first thing they kind of go through here of what DVD would you receive if you inserted your money and pressed A1. So, you could put hunger sports. So they're just getting you to see that there is a relation there. It gives you an output. Something comes of that when you go to A1. If you go to C2, I'm not going to write them all down. You can. You get The Light Knight. Okay. I don't know if that's Robin is The Light Knight. And then B3 is The Amazing Insect Man. So when you go to those different buttons, you get an output. Okay. Assuming the machine were filled properly, what would happen if you hit a button twice? Well, you should get two of those outputs that come from the same one. If I hit C1 twice, I should get two of the dependables. Okay, so it's getting you to think about those. So there's those words that I just used, and these are good ones. Yes, they're in your book, but circle, highlight, whatever for yourself. But we have input and output. Okay, does every input have an output on that DVD machine? Well, almost. Take a look at it real quick. And if we look at that, we say, okay, all of them but one really has an output. Hopefully we realize Sold Out is not a movie. Maybe it is. I'd have to look it up. I should and see if there is an actual movie named Sold Out. But I don't think there is. Well, for this sake, we're going to say that just means there is no actual movie in the sold out file. So that means if I hit B1, nothing would literally come out of the remove purchase DVDs here. Okay? So not all of them have an output, and that's a possibility sometimes. Okay? So every one of those combinations of input-output we can express as a mapping. So a mapping is just one way to represent a relation. So that's what they're saying here. It's a representation of a relation, a visual one. Okay, so you could make a mapping, which is just going to say you basically draw arrows for them. So if I was going to say, what happens if I press A1? Well, I would get the hunger sports. My writing's worse than usual because I'm just writing it quickly. What would happen? I'm going to go to B2 and B3 actually go to the same one. The Amazing Insect Man. Okay, so sometimes the input has the same output. Okay, so that's a possibility. What's another way we can illustrate this? Well, you could make a table. You could just go down and say, okay, A1, here's our input, here's our output. A1 has hunger sports. Go down the list. A2 has the Revengers. And you could make that table with it. Probably similar to what you've seen when you have X's and Y's. And look at what the next math term is. We talk about an ordered pair, like when you have an X as an input and a Y as an output. And we could write them as an ordered pair, like 2, 7. I inputted 2 usually as an X. The output I got was usually my Y of 7 if you plugged it into an equation. Okay, so there's all kinds of different ways you can write a relation. Okay, So ordered pairs, mappings, and tables. I'm going to jot those down here because those I would put on the side. So we have ordered pairs, tables, and mappings in no particular order are way that we could write that input-output relationship that is going to exist. Okay? All right. Here's an example up top of just they show you those and they add in one more. A graph can also be a representation of a relation. So here we're saying here's the mapping. 1 goes to 4, 2 goes to 3. And it's the same here. The table shows the same thing. The graph shows the same thing. At 1, I'm at 4. At 2, I'm at 3. At 6, I'm at 5. So it still shows the same input-output relationship. Okay? So here they're saying, all right, well, what if I had like a mapping? How would I write it as an ordered pair? Well, they show the first one, 1 comma negative 2, 2 comma 1. There's 3, 4 would be 3 comma 4, 4, 7 would be 4 comma 7. Okay, so it's just a way that you can write those out. Okay, all right, take a second here and pause and do the check your understanding. So I'm assuming you're pausing. I'm going to keep going. I'm not going to pause. We have a vending machine at the Ocean Road and Air Show creates the souvenir coins, and you're selecting it. So it's just trying to show, well, what am I going to get? Make a table showing each coin's letter number combination. So A5 would give me a ship. B2 would give me a train. So you could just make that. You should have made that combination there. Write them as an ordered pair. You know, A5, comma, ship. Okay, make a mapping diagram. A5, mappings, you just draw an arrow. Ship. Okay, so it's just getting you to say, okay, do I see what these are? Can I make a table? Can I write them with a comma as an ordered pair in parentheses? And can I make a mapping with them? Now, this is the other real big part here is, all right, we said relation. What about a function? A function is where each input is paired with exactly one output. So input to exactly one output. So there is a difference between a relation and a function. In a relation, it's just there's a relationship. You can have inputs that go to the same output. You could have an output that matches up with multiple inputs. Okay? But a function is very specific, and there's a quicker way to check it. So it says, suppose C1 on the vending machine, both the dependables and the light night come out. Okay? How is this not a function? Well, C1, if I did a mapping, it has 2 arrows coming from it. It has, I'm just going to abbreviate, TLK and TD. There is an input that goes and is paired with 2 outputs. That does not make it a function. A function would only have from the input an arrow going to one spot. Now, maybe you had like C1, and I don't have it in front of me now, D1, both went to the light night. I know there are 2 of those. That's okay, because the input is still going to only one output. Doesn't matter if it goes to the same output, that's okay. What we can't have for it to be a function is that the input has double outputs. Okay, that makes it not a function. Okay, so when we're looking at this, there's a really quick way when we have ordered pairs. We can tell if it's a function by looking at the x values. And if the x values repeat, it is not a function. That means an input has double outputs or triple outputs maybe. So I don't even have to look at the y values. I'm just going to look 5, 6, and 7. Are they all different? Yes. So this would be a function. 4, 4, and 5. Are they all different? No. 4 and 4 are the same. So this is not a function. I don't even care. Notice I'm not looking at the y's. Don't care what they are. Like here, 5, 6, 7. All different. That's a function. But if you look at the y's, they're all the same. 4, 4, and 4. That's okay. as long as you don't have an input that gives a double output. Okay. Now, here they're saying, would these be a function? Well, for every x value you plug in, you could go through and try them. You're going to have a unique y value. So yeah, it's a function. 1, if you plug in 1, 3 times 1 is 3, minus 5 is negative 2. It can't be anything else. So it has to be a function. Okay, so any of these that we call linear equations would be a function. All right, take a second again. We'll do the check your understanding. So again, pause for a moment, do this one on your own. And what we're going to look at here is, do you have any double input or inputs, that go to a double output? So go ahead and pause, and I'll go look. And then when you come back, I'll be right here. It's like magic. So 2 only goes to 6, 3 only goes to 7, 4 only goes to 7, 5 only goes to 9. So is this a function? Yes. If I had double lines, then it would be a no. All right, how do I check on a graph? Go to the x values and make sure there's only one dot in each spot. So 0, 1, 1, nothing, 2, has 3 and 5. Right there, is this a function? No, it would not be a function because you have an input of 2 and a double output. Some of you may have learned along the line too the vertical line test. We'll talk about that more too later. But if it comes up and you have on that vertical line any spot it crosses twice, it makes it not a function. Okay? So take a minute here again, and this is kind of the practice of it. I'll give you the answers here in a moment, but this is a chance for you to pause and just see, all right, do I have it? Do I get input, output? And especially then, do I get what a function is? So what output gives you I2? It's like a graph or a Excel spreadsheet. So I could label down here, they didn't give you 1, 2, 3, 4, 5, but I2 would be 23. What is 54? Well, 54 is at G4, so we're going backwards there. Does every input have a numerical, that's the key word there, output? No. Hopefully you put for that one, free space is not numerical. Okay. All right, explain why the each is not a function. Really, your answer should be, give me the spot that has a double input or an input, I keep flipping around, an input that gives a double output. So I'm looking at the graph, I'm looking for any 2 that are at the same x value. So at 1, I have 2 x values. So explain why it's not a function. Just at 1, it has a double output. When I look at the second one, I'm just looking at the x values. 12 is on its own. 17, nope. So why is this not a function? At 17, it has different outputs. It has 2 different answers for it. Can't work. Okay, and we're not going to worry. I should have told you earlier, if you tried C, don't worry about it, but would it be a function? No. Okay, or it was explaining why it wasn't anyways. So it's pretty straightforward with those. We're just trying to get you on the track of, is it a function? Is it not a function? And understanding that a relation is just, you have an input, you get an output. But a function is more specific. A function is, for every input, there is only one output that goes with it. Okay? Have a great day.